Hi, Doctor. The subject of our assignment is prediction for air quality index. The first part is introduction. In this assignment, we use the dataset from Global Meteorological Data Repository, and we focus on applying the first two steps of SIMR methodology to explore it. Then the assignment is structured into four major sections, which are business understanding, data description, methodology, and results. In business understanding, we analyze the goal. The main objective of this assignment is to perform data sampling and data exploration on the selected data set to understanding the correlations between weather parameters, pollutant concentration, and air quality index. In addition, we also identify if there are any outliers through the exploration, and we analyze the data set. Our dataset provides daily weather information for capital cities around the world. A quick overview of the dataset is shown. There are 185 countries with 197 unique locations and 27 filters. We divide it into three parts with meteorological parameters, environmental pollutant concentrations, and additional information. We listed the air quality index information on the levels of air pollution according to the Department for Environment, Food and Rural Affairs. We use SIMR methodology. It's a data mining framework to provide a structured and intuitive pathway for data analysis. Data scientists can follow a clear workflow under it. It concludes a sample, explore, modify, model, and assess. We will focus on the first two steps of samples and explorer.
Hi everyone, I am Boon Kiat. I will talk about the result, specifically the sample phase. The dataset was downloaded from Kaggle as a CSV file and imported into Teradata preparation for data cleaning. Originally, the dataset contains 41 columns. 14 columns were dropped because some of them are duplicated columns with different unit of measurements and do not provide additional information. For example, we kept temperature in degrees Celsius and draw temperature in degrees Fahrenheit. Additionally, some columns are removed because they are not important for air quality prediction, such as sunrise, sunset, moonrise, and moonset. We recategorize the values in the condition text column. Purpose is to group similar values together and make it easier to analyze data in the export phase. For example, we categorize fog and freezing fog as fog. In terms of sampling strategy, we decided to use the entire dataset due to the following reasons. The size of our dataset is relatively small when compared to the one depicted in the example report. According to SaaS Enterprise Minder ebook, using entire dataset in the export phase can help to examine data quality issues. In model phase, one way to determine if the sample size is appropriate is by evaluating the model accuracy. Sample methodology is flexible. It is possible to go back and forth between the phases as needed. Given that we did not identify any sampling problem in the export phase, we will proceed with using the entire dataset for the model phase. If the model phase reveals that the model has low accuracy, we can return to the sample phase to refine the sampling strategy. Otherwise, our decision is to use the entire dataset. Metadata provides information about the variables such as their roles and measurement levels. In SaaS Enterprise Minder, column metadata can be defined using either the basic or advanced settings. In basic setting, all the variables except location name are assigned the input role. This is not true because there should be a target role and ID variable. Similarly, target variable and ID variable are still not defined by the advanced setting. Therefore, the column metadata defined by both basic and advanced setting cannot be accepted. The roles and measurement levels of some variables were manually reclassified to correctly define the column metadata. Air quality index variable was assigned the role of target, given that the main goal of analysis is to predict air quality index. The last emitter variable was assigned the role of time ID because it contains a timestamp. The moon phase variable was rejected because the moon phase is not important for air quality prediction.
Summary statistics. Upon assessing and examining the dataset, a set of summary statistics is produced. The purpose of these summary statistics is to provide an overview of the data pattern, encompassing details like minimal and maximal values, mean presence of missing values, and standard deviation. The figure 5.5 displays the summary statistics for interval and it shows that our dataset is free from missing values. Next part is univariate analysis. As can be seen from the figure, Most of the nitrogen dioxide concentration is below 100 microgram cube meter, and this part accounts for more than 90%. As shown in the picture, the sulfur dioxide has a similar trend to nitrogen dioxide. However, sulfur dioxide has a higher percentage in having concentration less than 12.5 microgram cube meter as compared to the nitrogen dioxide. Most PM2.5 concentrations are less than 100 microgram cubic meter. Most PM10 concentrations are less than 50 microgram cubic meter. The weather conditions are mostly partly cloudy and clear, and these two types account for most of the conditions. In the AQI, lower values correspond to better air quality, while higher values indicate worse air quality. Specifically, AQI values are graded and range from 1 to 10. Most of the AQI in the picture are 1 to 3, indicating that the air quality is good and there is almost no risk to health.
Hi, I'm Wong Jihui, and now I will be presenting the bivariate analysis part. In this slide, it consists of 6 charts which study the relationship between different pollutants concentration and the AQI. Based on the visualization, we can categorize those charts into 2 categories, which are pollutants that have positive correlation with AQI and pollutants that have no correlation with AQI. For the first category, there is 5 types of pollutants, whereas the second category has only 1 pollutant. Besides, we also carry out bivariate analysis on the meteorological variables and found that visibility and wind speed have negative correlation with AQI. Next, I will talk about the multivariate analysis, which I have only selected a few important charts to showcase in this presentation. For the first one, bubble plot is used to study relationships between 3 variables, which are precipitation, weather condition, and AQI. It shows that precipitation has negative correlation to AQI and is also influenced by weather conditions. Next, this is a 4-variable analysis using PM10, PM2.5, AQI, and weather conditions. The visualization shows that both PM10 and PM2.5 has positive correlation with AQI and also partially affected by the weather conditions. Lastly, this is a bar chart which combines all the pollutants variables and studies the relationship between total air pollutants concentration and AQI. It shows that the total air pollutants concentration has positive correlation with AQI. For the conclusions, after the simple data cleaning using tailored data prep, the dataset used for our work assignment contains a total of 27 variables. The revised dataset has the following metadata as shown in the table. Based on the findings from exploration part, the objective of our assignment are achieved as elaborated in below table. In terms of the comparison with the source sales data, we have similar outcomes from the exploration phase as the EDA able to identify data errors and pinpoint important features that correlated with our target variable. The primary distinction in our exploration phase lies in our dataset, which we do not consider time ID or date since it does not have any effect on AQI. That's all for our presentation. Thank you.